Hello everyone, this is Rebecca Arvin with the Water Environment Federation. I want to welcome each of you to the Using TOC to Replace BOD Requirements, sponsored by Shimazu Scientific Instruments. Before we begin, I would like to quickly review a few logistics. All of the PDF PowerPoint presentations are available for downloading at WEF's SCP link. This link was distributed via email yesterday and will be distributed again tomorrow for anyone that registered after the time of distribution. The FTP link for this webcast also has information on how to receive professional development hours for those eligible to receive these training credits. There are 2 PDH credits for this webcast. You will need to complete the evaluation form to receive the PDH certificate. Your feedback on this webcast is important and helps identify future webcast topics that are timely and helpful to you. Please follow the PDH instructions and check with your state accreditation agency on how to receive this credit. During this webcast, while you cannot speak directly to the presenters, you will, however, have an opportunity to submit questions by typing in your specific question via the question pane that appears on your PC. Today's moderator, Jennifer Loudon, will be accumulating questions and direct them to the presenters at the end of the webcast. We will be recording this webcast. A link will be sent to all registered users tomorrow so that you can share it with other colleagues who could not attend the webcast. If you have any additional questions after the webcast has ended, please email webcast with an S at wef.org. Before we get started, I have a poll question for everyone. Let me go ahead and launch it. It's how many people are participating in the webcast today at your computer. If you're participating by yourself, please respond 1. If you're participating in a conference room, for example, or have several people gathered around your computer, please do a quick head count. And Jean asked a question, if there are handouts available. I'll go ahead and type the FTP link into the chat box so you can get that link. Great, it looks like everyone's voted. So I'll go ahead and share those results. We have about 78% today participating by themselves. So I'd like to thank Jennifer for moderating the webcast today. Jennifer Loudon is a laboratory manager at Raritan Township Municipal Utilities Authority. Jennifer?
Thank you very much. It can be a mouthful, I know. I just wanted to quickly put things in perspective as far as how TOC relates to BOD, just so everyone starts out on the same page. TOC, or total organic carbon, is the sum concentration of all the carbon-containing organic compounds in a wastewater sample. These compounds then go on to be oxidized by biological or chemical processes, which are then measured by BOD and COD respectively. So now that everyone has an idea of how the parameters fit together, I would like to start the webcast and discuss using TOC to replace BOD requirements. And I'm pleased to introduce our first speaker this afternoon, Ms. Nell Grunfeld. Please hang on for just one moment. Nell has 27 years of experience in an environmental laboratory. She received her bachelor's in soil and plant biology from UC Berkeley and then went on to join the Inland Empire Utilities Agency. She started as a chemist, went on to become supervising chemist, and finally in 2005 was appointed the laboratory manager. So thank you, Nell, and we look forward to your presentation.
Thank you, Jen. We kind of started this process about 20 years ago, so I'm going to step you through what we did and how we got to where we are now. So as I said, about 20 years ago, we were known as Chino Basin Municipal Water District. And I mention that because our original paperwork, the letters that went to the regional board, have that name on it. And that document has been distributed, and people have been confused and not know who to contact regarding information on it. They've tried calling City of Chino and other stuff and kind of gotten lost. So I wanted to make sure that we're now called Inland Empire Utilities Agency, but original documents might have Chino Basin Municipal Water District on there. So we started by sending off a letter to the regional board with a request to convert COD to TOC. And that was actually accepted fairly quickly. At the same time, we sent some correlation data to them to show that TOC correlated to BOD. At that time, they did not allow us to switch over. We had to go through a little bit more of a process for this. In '95, our NPDES permits contained provisions to allow us to substitute TOC for BOD if we could show a correlation. So obviously they wanted some more data, which over the next 2 years we did. We had some requests to also submit some additional data to them during this time. So as you can see, it took a few years, but in '97 we were successful, and we submitted our final data and was given approval to switch over. And basically our permits now contain the wording, they require us to continually monitor BOD and TOC, but there is a note in our permit that says we can use the calculation from TOC to report BOD and also to use BOD, TOC, the calculation for our compliance limitations. So the drivers for getting us to this point, of course, back in the day, CODs, we used to use the open reflux titrometric method, so it actually had a fairly large volume. The manager then didn't particularly like the colorimetric method, didn't feel that we got consistent results. So obviously TOC uses a lot less chemicals, a lot safer, no sulfuric acid or chrome, and a faster turnaround time, so you've got minutes compared to hours. For BOD, same thing, obviously a faster turnaround time. You go from minutes versus days, and certainly less time consuming to prepare a sample and analyze the sample, just physical time of the analyst performing the test. You've got more accuracy with TOC. There's so many variables, the temperature of your incubator, a lot of issues with the BOD test. You get very good QC on the TOC. And certainly your analysis is complete prior to the whole time being exceeded, so you can repeat if you have a problem. So that's a big bonus. And with 3 treatment plants at the time, we now have 4. We could have anywhere 15 to 20 samples a day, and so this was a huge time and cost savings for us. So a big driver was also because it's a terrific operational process tool. And one of the speakers that will be speaking later, Doug Drury, was here at the time, and he really helped initiate this process because he understood and he knew that having data the same day was very beneficial. So that was a huge driver. And I believe we actually switched our process sampling over to TOC well before we did the compliance because we were comfortable enough with that data. And so obviously, again, the cost and time savings to the laboratory. So the process we took was performed just a ton of analysis on various samples. We used process samples, we used influent and effluent compliance samples. So we used primaries, secondaries, and then just dumped all the data, did a data analysis, performed linear regression analysis on this data, and we communicated frequently with the regional board. As I said, we kind of went back and forth with the BOD. We had to submit more additional data. So that worked out pretty well for us. So the instruments we used. So back in the day, we had an old Rosemont Analytical DC-190. I don't even have a picture of it. I do have pictures of the other ones, the newer instruments, so I'll show you those. But this instrument, we found that it worked better using total carbon, subtracting the IC, and calculating the TOC. Just seemed to work better with this instrument. It had a 1-point calibration, so you really had to dilute your samples to kind of get within a fairly close range to that calibration data point. We actually, at the time, used the IC data to calculate an alkalinity value. And this worked pretty well. Since then, we've kind of automated alkalinity, and we no longer do that part of it because in 2001, we purchased a new instrument, the Apollo 9000. These are both combustion instruments. So both have a detection limit of 1 ppm. And both of the instruments, you also need to make sure that you have a large sample line to collect the sample because of the particulate matter in the sample, especially the influent. And we also found blending, homogenizing the samples by blending them makes a big difference as well. You're able to break down the larger particles and get them to pull through the line. These are fairly small sampling lines on these instruments. So we upgraded 2001, and now we have an instrument that we could do multiple point calibrations. It's also combustion, so it has a detection level of 1 ppm, and these are better for samples, the dirty type samples, your influent. And so then about 2006, we purchased the persulfate UV instrument, the Phoenix, because we were getting into groundwater recharge at that time and needed to meet a lower detection level for the wells that we were monitoring for our groundwater recharge program. We had to meet drinking water levels, so we had to go down to 0.1. And so what we decided at the time, because the sensitivity is better at the low levels, we went ahead and started analyzing our effluents on the persulfate UV instrument as well, which worked really well because most of our samples, our final effluent, we discharged TOC is less than 10. And so it worked very well for us because there's no particulate matter in these samples, which you really wouldn't want to have when you run TOC on the persulfate UV. So currently, we've actually upgraded again. We are combustion. We still use the same persulfate UV instrument, but the combustion one we upgraded one more time. We pretty much use these things a lot and really wear them out. The new instrument, we've had to play a little bit with it to get some really good data. We found that their mixing of the sample after you add the acid to remove the IC, we ran into a few issues, but finally kind of worked it out where we have some mixing being done in the actual auto sampler, and that's where we add the acid and purge the sample, mix the sample, and then pull it through the instrument as opposed to purging in the purger on the instrument itself. With the dirty samples on the influent, you tend to build up scum quickly in the purger, so if you run it in your sample vials, it works a lot better, and you're not having to clean that as much and not worrying about its contamination quite as much. And both, since 2001, we've been measuring just the TOC direct by getting rid of the IC. Just the alkalinity seems to work fine. We run those on a regular alkalinity instrument that's automated, so it hasn't made a difference there time-wise. So this is the Apollo that we were using for a while. I've shown it with the cover on, cover off. I don't know. You can see there's the sample gets pulled in, and then it can be run through a purger where the acid's added there, or the acid can be added with a mixing type sampler. You have to get a magnetic stir underneath the vials, and then you add a little tiny stir bar to each vial, and it mixes it, as well as purge, so you kind of get a double mixing going on. This is the Phoenix UV. You can see the UV light on there. It actually uses a larger volume of samples, so you really are going to deal with lower level samples when you use this instrument. Don't worry so much about the mixing on the sampler, and you do purge with the acid, removing the IC in the instrument itself in the purger. And this is the torch. And as I said, we actually had to replace the auto sampler with one that you could mix. And I think you can see the tiny stir bars in there, and then there's also a line that purges a little bit as well. And we seem to have worked out some of the bugs that we had with this one. So I'm going to show our correlation for TOC to COD. I'm not going to spend a lot of time with this. As I said, this was proved to be a very good correlation. The regional board readily removed COD from any permit requirements, and we really haven't even dealt with COD in the plants. We still do some CODs for industry-type samples, but within the plants, influence effluent, we don't even deal with COD. So my next slide is our first correlation that we did for TOC and BOD. This was back in '97. This was the one we actually submitted in the calculation that we used. As you can see, we had an excellent correlation coefficient of 0.925. And unfortunately, at the time, when we ran BODs, we ran BODs with 150 mils of sample instead of the full 300. So we were reporting less than 4 for our detection limit for BOD. So the data we got down at that level was just kind of useless to us. And so we just did the calculation using primary influence, effluent, and raw influent data. What we found was if a TOC of 25 would need to be seen to get a BOD of 20. And so what we did was, if we ever saw a TOC of 20 or above, we would actually do a real BOD just to confirm that we were below the compliance level of 20. And actually, we continue to do that, although we've actually lowered that to 18. And over the years since I've been here and we've made this change to the TOC calculation for BOD, I think we may have done BOD, a real BOD, about twice on a sample that we had that was over 20 in all these years. So it's very rare for us to get TOCs at that level. So then in 2002, we started doing BODs with 300 mils so we could report a less than 2. Went ahead and just threw that data in here and did a new correlation. It actually came out fairly similar, and it wasn't a big change in the calculation. We continue to monitor anything. We would do a real BOD if it was a TOC was greater than 20. In 2008, we again updated our calculations. I don't have the graphs for these. I do have some further graphs to show the difference here. Back then, what we did, because this is, if you remember, in about 2006, we bought the persulfate UV. So we started getting more accurate, and we could carry out our data to a decimal, 1 decimal place for TOC at the low level. So we actually did separate calculations for the influent and the effluent. And the influent calculation remained fairly similar to what we had had before. The effluent calculation is significantly different, and we only use that calculation when samples are below 10 TOC. So, oops, I think I got a little too ahead of myself here. Sorry about that. So, as I mentioned, I kind of flipped slides, sorry. This is an ongoing process. So we continue to monitor BOD on our influence and effluence about once a month, just to continuously collect data because conditions change. Actually, your potentially even your influent may change a little bit coming in, and we want to continue to monitor that to make sure that the calculation is still applicable. And so, as I said, in 2008, we updated our calculations again. So now here we are. It's 2013. It seems like it runs about every 5 to 6 years that we want to update it. And I've got this data out here. It is preliminary at this time, and I probably should have put a note on there. We are finding kind of a big change in our calculation this time. So we're probably going to take a better look at some of this data and understand why and what's happening. I wish I had the answer for you today, but I don't. I'm not quite sure why it changed so much. If I know our influence strength has become a little stronger because of all the conservation efforts we've done in the area, and so that may be a factor in this. I'm not real sure. And the other thing is that the correlation coefficient has actually gone down some. We used to run pretty much around 0.9 for those. We're running about 0.76 for the correlation coefficient. That's just R. What my screen is showing is R squared. I like to use R correlation coefficients better because that gives you the strength of the linear relationship as opposed to the proportion of variability. It's nice to just use the actual linear strength. So as I said, we're kind of looking at this data some more. We may find that it has changed significantly and that we need to go with this new calculation. So here's a chart of the effluent data. And as you can see, it looks a little messy, doesn't look real linear, but you're dealing with samples that are pretty much less than the detection limit for BOD. And what we do is we just sort of ignore the fact that there is a detection level for BOD and go ahead and use the raw data to calculate our correlation. And you kind of come up with this funny little correlation. The data is sort of just bunched all down there together. But the good thing is our TOCs tend not to run above 7. As you can see, about the highest I have here is about a 6.5, and this is, I believe, about a year's worth of data. So, and we're very consistently show that anything below 7 TOC shows either a non-detect or possibly a 2 BOD, milligrams per liter of BOD. And so that's been a really good thing. For us, it clearly shows that there is no BOD at those levels of TOC. So some of the challenges that we've gone through to get this implemented, and like I said, this is quite a few years ago that we did it, and so at this point and at this agency, the operations have pretty much switched over. They don't even think in terms of BOD anymore, so it's been pretty good. And really what I have to admit is Doug probably helped us get there early on since he was a very big proponent of switching over. So at that time, making the conversion wasn't too much of a challenge. There's still a few out there that want to actually see that calculation and be able to convert TOC to BOD because they just still look at it that way when they're doing their process control. So, but for the most part, this agency has switched over fairly easily. So initially, we really had a lot of hopes that we'd be able to convert from using BOD to TOC for our industrial waste samples. We have a lot of industries in our area, and it would just be an exorbitant challenge for us to take every industry's discharge and do a correlation. So we've just maintained using either COD in some areas where that's a requirement or BOD, and find that the number of samples hasn't been such an issue that that's hard for us to do. So, I mean, if you're an agency that has a few industries that are fairly similar or just a couple, you might be able to convert over for those, but there's just too many different matrices for us to make a switch like that. And certainly one of the big challenges are, now that you've got operations on board, the last thing they need to hear is the instrument's down and we can't give them data because they start relying on that data. So really have staff trained on maintaining the instrument, take care of it, have a good maintenance agreement because there's obviously times when you're just not going to know how to fix it. The flip side of that actually is that if you do have a failure, you can certainly preserve the samples and you have a 28-day holding time. So for compliance purposes, you can still meet those requirements and you don't miss samples because we have daily TOC BOD requirements at all our facilities. So this really helps with that because obviously with a 5-day test on BOD, but the hold time is 1 day or 2 days, I guess, you just don't have a chance to repeat stuff, or if you have a failure with an incubator or something, you're just not going to be able to produce data unless you send it out to a contract lab, which then, of course, is going to add in some additional costs. So, but just maintain the instrument, it's very important. And really, I think this is pretty much it. I'm done with my portion. In summary, TOC correlates very well with COD and BOD. It's very useful for studies when you get just a ton of samples from operations that want to do a study. You can quickly get through that data for them, and money and time saved. So that concludes my portion of the presentation today. Thank you.
Thank you, Nell. Just a reminder, we're going to hold all of our questions until the end, so by all means keep them coming in, and hopefully we'll be able to get to them afterwards. Our next speaker is Mr. Akin Babatola. He received his bachelor's in microbiology, and he has a master's in molecular biology. His career started in 1993 as a research microbiologist and process lab section manager for the City of San Jose Environmental Services Department Laboratory, and then he moved on to his current position as the Laboratory and Environmental Compliance Manager for the City of Santa Cruz. He has successfully led development of site-specific BOD TOC conversion equations in the City of Santa Cruz, as well as led the conversion from MPN techniques to membrane filtration techniques for bacterial monitoring of environmental samples for the City of Santa Cruz. He introduced the integrated sampling mechanisms to effectively monitor for trace organic compounds in wastewater and source control efforts at the City of Santa Cruz. And everything that he's been doing on is now in successive renewals in permitting for the City of Santa Cruz. So definitely very involved in introducing techniques and continuing to progress the field. And without further ado, I am pleased to present Mr. Akin Babatola.
Thank you, Jen, and thank you all the subscribers to the webcast, and I hope we are able to add to the slew of information that people need to move to more efficient processes with this webinar. My section of this webinar is to focus on how the City of Santa Cruz's wastewater treatment facility laboratory was able to successfully develop site-specific equations for converting BOD to TOC, both for process control as well as for the MPDES program of the city. And our objectives were clear because we needed, like my predecessor stated, something to assist operations to give them a reliable and rapid option for controlling their processes. As everybody knows, by definition, BOD is a 5-day test. The detention time for wastewater at the City of Santa Cruz is less than 24 hours. So if you're going to treat it and you needed information, analytical information, you're going to have to resort to methods that will not be BOD. And we also needed to do to maintain compliance with our MPDES effluent discharge limits. Like my predecessor, we had a history of nothing but BOD data, and all previous permits were written in BOD terms. In fact, the national limit for comparing plant efficiency is all written in BOD terms. However, the Clean Water Act, in its slide that I will show you subsequently, allows for the conversion from BOD to either TOC or COD, providing that long-term studies have shown correlation. And so our objective was to comply with that provision of the Clean Water Act and thereby be able to revise our MPDES permit, as well as allow process control options that truly would allow for treatment of the water. And I've got to emphasize that this is a small city. Santa Cruz population is less than 60,000. Some institutions, some municipalities are able to maintain BOD and TOC simultaneously because they're large, but that's not the case with the City of Santa Cruz. And we also wanted to maintain the level of the laboratory's budget. So both in terms of the size and the interest of the community, we needed something that would be at the same budget level or even slightly better in terms of efficiency, cost efficiency. And we saw TOC as a good candidate for that. And finally, and this is crucial, we wanted to continue to maintain our cooperation with the regional board during the processes. It's not sufficient, not even adequate, that you're able to show the relationship between the technical parameters. It's equally critical, perhaps more so, that you engage the regulators in dialogue while you're doing it so that you have an efficient process. And we're able to do just that. I'd like to emphasize that, so if I'm successful in this section of the webinar, I would have illustrated to you the clear and some obscure challenges that we had to overcome. And I'd like to be able to have illustrated successfully the institutional advantages that we had for making the transition, and to show a third and successful pathway to transition from BOD to TOC. Inland Empire presenters before me had told you one method, and the presenters after me will show you yet another method. So it seems quite easy once one wraps their mind on the fact that we're talking about organic carbon. And all of our instrumentation are able to actually do total carbon, inorganic carbon, and total organic carbon. But we're focused here on total organic carbon because that was the intent of BOD in spite of its errors. In our city, we had a 30-day effluent limit in our NPDES permit of 30 parts per million for BOD. Again, that's a nationally derived performance limit for secondary plants. So our challenge would be to get the TOC equivalent value and to bring our regulators along with us, but we're doing that. We also had a 7-day limit of the BOD average of 45. So we were having to do BOD every 6th day. That was the best it could do for us anyway. And yet we had to calculate a 45-day average of the BOD. With TOC, of course, you have way more flexibility than that. You can do TOC practically every day and get a true average. So this was already loaded in our favor, I think. And finally, among the clear challenges, we had to convert our legacy BOD data to TOC for not only process control, but for pretreatment program data and analysis. When you have dischargers that have been regulated in terms of their BOD loads, and you're going to convert them to TOC, you would need to adopt one of two options: the option that Inland Empire adopted, or do this equation for them specifically to be able to get the TOC values and your pretreatment program to be able to regulate them as such. And those were the clearer challenges that we faced. The obscure challenges were to derive the site-specific equivalent of the percentage TOC removal, which is a standard requirement of all POTWs. That national average is a 30-day minimum of 85% average BOD removal. So you've got to be able to calculate what the percentage removal of TOC would be. As you've already seen from the first presentation, the relationship between TOC and BOD is linear, but it is not 1-to-1. It's not 1 part BOD equals 1 part TOC. BOD is particularly inaccurate at very low levels. And as you saw in one of the slides shown by my predecessor, it bunches up numbers around 2 or below. You're not even supposed to measure at those levels, and therefore it's difficult to measure efficiency when you're comparing it to BOD, which is just a glub at the low end. And of course, deriving from that is the other cluster of data that BOD has in highly efficient processes. It won't change much, but TOC might be fine enough to show changes there. And so that would be difficult to interpret. So those are the two obscure challenges that we had. In our favor, we had the legal authority, which I mentioned earlier that I was going to show in this slide, that at 40 CFR 104, Part B 133.104, an integral part of the Clean Water Act, states that sampling and testing procedures, COD or TOC, may be substituted for BOD when a long-term BOD-COD or BOD-TOC correlation has been demonstrated. This is a major hurdle to overcome. Once it's stated in law, you have the law on your side, and now you have technology on your side. The relationship is a third part of that equation that you need to be able to get your regulators to come aboard. I left here some working definitions for the elements that we're going to be dealing with: 5-day BOD, COD, and TOC. In the interest of time, I will not be going over them, but these slides will be available to you, and the reference resources will be provided also. We also had economic considerations for what we were going to do, and these considerations are the same, maybe even better now for those who will be coming after us. In essence, we had to compare how much it would cost to continue to do BOD versus how much it costs to invest in a TOC system. This slide shows you, for my city, what it would cost if we used the survey that was recently conducted by one of the agencies engaged here. It shows essentially that we would have ended up paying $26,000 per annum for the minimum level of BOD that we did, whereas a TOC system costs $20,000. And we've used the same instrument for 7 years. So it's more than paid for itself, and it's been savings every year since then. So even for economic considerations, once you're able to show the equivalence between BOD and TOC, it'll be prudent to switch to TOC. So the stages that we engaged in our crossover, we didn't have the benefit of knowing that Inland Empire had gone ahead and was able to successfully study. So we had to do some confidence building analysis in our city. And the first stage was trying to find out if we could develop a relationship, if we could show that there was a relationship between TOC and BOD. We compiled data over a period of 12 months, which gave us sufficient confidence that yes, there was a linear relationship, highly reproducible, highly effective. In fact, it became a game of sorts in the laboratory where the chemist, who was principally in charge of this conversion exercise, would wager and predict what the BOD, because we were still under the BOD permit at the time of this development, would wager on what the BOD would be in the final effluent at the end of 5 days, and she would always be right. So here's a small table that showed easily what we saw then between influent BOD TOC and the TOC BOD ratios. It shows that we had a maximum with given natural fluctuation of 0.58 TOC to BOD and 0.31 at a minimum, and the average was 0.44. So we were confident that we were dealing with something that was trackable. And here is the chart that was developed from the first set of equations for over a year, from November 2005 through November 2006. It was a linear relationship. As I said before, correlation coefficient was over 80%, and the equation was obvious and very encouraging. So at that point, we decided that we could go forward and ask the regional board's permission to do the conversion. Among the information that I called and I didn't put in here was that we also had a problem with our temperature control in the building. And estimates were that at a minimum, the laboratory could be temperature controlled for about $36,000, or the building that hosted the laboratory could be controlled at the same time for twice that value. Well, the most recent estimate of doing that HVAC project is over $180,000. So instead of waiting and haggling over that provision, we simply decided that we could buy an instrument that would give us a confident way of getting the data needed, which was a TOC instrument. It wouldn't cost the same as controlling the temperature of the entire laboratory, which BOD would have required of us, and we would do it efficiently and fast. So we wrote all that into our request to the regional board. And we had to revisit that once the request got to US EPA level. So we did have an equation that gave us that confidence, and we did have the reason that we needed to control costs without busting our budget, and that we knew we could use the initial data to do source control and procurement applications, because those were strictly affecting only the influent. And we then went forward and made our request to the regional board. And the initial data that we had also, we had to pull together to show them the statistics of it. This, by the way, has been published in full. Each data point and all the average data points have all been published in WEF Lab Solutions. I think that was published in 2005, but you'll see the reference at the end of this presentation. So this was the curve for the effluent. As I stated before, and as Inland Empire before me had demonstrated, BOD tends to cluster at low ends. So the smart thing to do was to calculate using the TOC BOD ratios rather than the TOC value against the BOD value. So we use the TOC BOD ratio in the effluent versus the effluent BOD itself, and it showed an equation that was reproducible with a very high correlation. This was also a confidence building measure. At the end of this, we were able to confirm the feasibility of our effort to derive site-specific equations in line with what the Clean Water Act stipulates at 40 CFR 104. The resulting equation was that TOC over BOD was 9 times BOD minus a little value with a very high correlation. Excuse me. So we were now along to looking at the process control. We're starting to look inside of the plant. Now we're satisfied ourselves we can use it to control the influent. Starting to look inside of the plant to have a long-term study and to cover each of the unit processes, the influent, the secondary influent, the secondary effluent, and the final effluent. And we were able to develop all of that in graphs that I'm going to be showing you, because all of that needed to be aggregated to get a site-specific equation for the facility. And this is how that looks. Down here where you see a cluster of numbers is where the effluent is. And that has been universally true for every presentation I've seen since then. The rest of the data is for all of the unit processes, including influent and influent, primary influent, primary effluent, and secondary influent. All of that lines up along this linear equation. So we now had a basis for TOC and BOD interconversion for process control. We knew that each stage was controllable, and we were doing very well with our equation, which says that TOC is really less than half of our BOD for the most part. TOC is 0.4 BOD plus a constant of 4.3937. And you can understand the constant because, like we all said, BOD has a essentially a regulated detection limit because it doesn't have accuracy at that level of 2. And based on the high quality of this study, its duration and results, the executive officer of our board modified the specific areas of the permit to allow us the following. We now have in our permit, with the acquiescence of US EPA also, a limit of 17 parts per million of TOC instead of the 25, I think it was written in our BOD before. We replaced the 7-day average limit of BOD with a 25 parts per million of TOC instead of the 45 parts per million of BOD. But we were not able to replace the 30-day minimum 85% BOD removal because that's a nationally derived average. That's a performance base that involves some political and safety considerations and all that. We do remove better than that. We used to be able to, if we calculated the BOD anyway, we'd normally remove slightly north of 90%, but it was difficult to peg down what the national 85% would be because you don't impose that on a site-specific. That's imposed on the technologies that are used to treat water to secondary level, and that has to be done still. And this is just information about the number of data points that were used for deriving those last set of equations. And again, this will be made available to you. Our conclusion was that our study demonstrated the feasibility of developing site-specific TOC values for the regulation of effluents in wastewater. Briefly put, that means you can get your, what used to be your BOD in TOC terms, working with your regional board and with US EPA. The development also allows for greater efficiency in operation. In our city, we were able to develop a big chart, a normal graph is what you would call it, that our operations uses to convert legacy information that they had in BOD terms to TOC. I want to acknowledge the principal chemist who assisted me. She's retired now. She was very encouraging even when I was discouraged because of the complexity of BOD at the low end. She plugged through it. She is retired. And her assistant who worked with her, who's now the principal chemist who runs TOC in the laboratory, Ann Birch. And that ends my presentation.
Thank you, Akin. Once again, we're holding our questions till the end, so please be patient. Our last speaker, last but certainly not least, is Dr. Doug Drury. He has a master's degree in sanitary engineering and a PhD in environmental engineering. He has over 40 years of experience in the wastewater treatment field. He's designed, built, and operated wastewater treatment plants to remove nitrogen, phosphorus, and toxic trace organics. And he's now serving as Assistant General Manager of Water Quality Research and Technical Services for the Clark County Water Reclamation District in Las Vegas, Nevada. An interesting tidbit, prior to coming to Las Vegas, he was the Executive Manager of Operations at the IEUA in Chino, California, which is where our first presenter was from. So, without further ado, I am pleased to present Mr. Doug Drury in one moment. Okay, while we're waiting for Mr. Drury to load the presentation, I actually have a question, Akin. Are there any additional references that you can cite to support the migration away from BOD to TOC?
This is Akin. In my presentation, I had left on the very last slide an active link to a publication that was generously forwarded to all of us that shows an international study that shows, yes, there is an international study that shows the conversion exercise. It includes efforts by the city of San Francisco, California here, but other cities too. Yes, there is one more reference. It's at the end of my presentation.
Okay, thank you very much. And with that, I believe Dr. Drury is now ready.
Thank you. As you can see from the title, we have converted our thinking to TOC and no longer use BOD or COD. We're here now at Clark County Water Reclamation District, but 20 years previously, I was at Inland Empire Utilities Agency, and we've implemented using the TOC to predict BODs, and we've done it for 20 years. We've done it in 2 different agencies, 6 different treatment plants in 2 different states. Presently, at Clark County, we're the largest dischargers of the Colorado River. We're the largest discharger in the state of Nevada. We have over 100 MGD treatment plant, and it's advanced treatment. We do both phosphorus and nitrogen removal. At CCWRD, our final effluent is less than 2 milligrams per liter. We have 95 to 99% of our data for effluent BOD is less than 2. In addition, we have a waste flow allocation. That means as the flows increase, the pounds of pollutants have to remain the same, so therefore the concentrations decrease with time. As we improve our treatment process, we need to improve our treatment methods. Our critical parameters for us from the operational standpoint are both phosphorus and nitrogen. In the evolution of our treatment plant, we're originally trickling filter plant. Then came phosphorus removal. We added lime and alum addition. We presently have enhanced biological phosphorus removal. That means we feed chemicals, ferric chloride and polymer in our primary clarifiers. We do biological nitrogen phosphorus removal in our activated sludge process. And then we add alum before our tertiary filters to get phosphorus levels. And the phosphorus levels for our plant are average about 0.08 milligrams per liter. This gives you an idea of where we are. in the Las Vegas. This dark area here is the Las Vegas Valley. You see our treatment plant, we discharge into the Las Vegas Wash, which discharges into the Las Vegas Bay, and eventually goes out, and you can see the drinking water intake. So the drinking water intake is below or downstream of our effluent, and so we drink our own effluent. That means that we have indirect potable reuse, and which has more stringent requirements than just discharging an effluent to receiving water. Over the years, the term BOD has had two common uses. One is to quantify the oxygen demand. That means you want to control the DO in the receiving water, make sure you don't have low DOs, and then how much air to supply to the activated sludge process. In addition, we described the strength of the pollutant, or the amount of organic matter, and so this has been used for regulatory purposes to describe percent removals. And there's a general description of what we're doing. We have organic matter, we oxidize it with oxygen in the presence of bacteria, and produces carbon dioxide. So the BOD test is a measurement of how much oxygen was consumed. The TOC test measures how much carbon dioxide was produced. So both tests are trying to describe the same reaction. In terms of BOD, it has been used since 1910s. So it has a long history from a regulatory standpoint and a legal standpoint. The COD test was developed in the 1940s, and the total organic carbon was developed in the 1960s. The advantages of the BOD test are the long traditions of use and the ease of disposing of the test, the liquid waste, down the drain. The disadvantages of the BOD test are its high variability, it's labor intensive, the quality of the analysis is dependent upon the technique and skill of the technician and the reproducibility that the technician can produce. As was previously said, it's a 5-day test, which is past allowable holding time. The 5 days was established for how long the average time in England for the rivers to reach the ocean. That's no longer the case. And by definition, it has a detection limit of 2 milligrams per liter. The BOD for tertiary filtration plants generally run 99% of the effluents less than 2 milligrams per liter. Therefore, before you run the test, you're 95% accurate by guessing what the number would be before you do the test, and that's less than 2. And I perceive that as being wasted time and wasted effort, which means money down the drain. You could get more data, better data by using other methods. The results are useful for the permit, but they're not useful for operations. In California, when we implemented using the TOC, it was because of the information for the operators. Here in Nevada, we've implemented it just to save on wasted effort, but it actually saves money and saves time. As we stated before, both the BOD and suspended solids have been written into the Clean Water Act. From a COD standpoint, the advantages of its test is it's less than 8 hours to complete. And probably the biggest advantage is that engineers early on realized that there's high variability in the BOD test. So when they developed their own computer models, they did not use BOD, they chose to use COD. The other advantages is that you can reanalyze the analysis if you have a problem with it on the same day. And it does require less volume of sample than the BOD test. The biggest disadvantages from our standpoint is that it's hazardous waste and it must be disposed of in a different manner. TOC advantages are less than 4 hours to complete. You have a detection limit that's as low as 0.1. There's no hazardous waste being generated. It's a more precise measurement of the organic matter that's there. And I think probably better than anything, there's excellent inter-laboratory reproducibility on the test. In addition, you can analyze total nitrogen simultaneously, and in our laboratory, we figured that the cost for a TOC test is 1/3 of the cost for a BOD and total nitrogen test. So therefore, significant cost savings for us. Of course, the disadvantages is the lack of tradition. As we improve our water quality coming out of our treatment plant, TOC becomes a parameter of choice. EPA has selected TOC in order to describe the source waters for a drinking water plant. In the state of California, indirect potable reuse requirements have been described as a matter of TOC, and they chose both agencies have chosen TOC over BOD. This is a slide from an EPA presentation showing the characterization of source water and somewhere between 2 to 8 milligrams per liter of organic carbon. For indirect potable reuse in the state of California, the TOC has to be less than 0.5, therefore needing the requirement of having a detection limit of 0.1, which was discussed earlier by one of the previous presenters. Summary of the detection limits. TOC, you can have a detection limit somewhere between 0.1 and 1. COD, the detection limit is somewhere between 1 and 5 milligrams per liter. And of course, BOD by definition is 2. Again, because of the improved treatment technologies and the improvement in the water quality coming from our treatment plants, that is making the BOD and COD tests less useful. And better quality of water needs better test methods. So we should be improving as we go in terms of trying to describe our effluent as it gets better and better. Now, in terms of use, we're using the TOC to estimate BOD. There's a relationship. Both presenters have shown some correlations. I'll show you quickly some of ours. But we need to know that the correlations between BOD and TOC vary with the effluent, primary effluent or secondary effluent. It varies with the different plants and their locations, and it varies with secondary treatment processes. Here's an example of a correlation that we have done at one of our treatment plants. As you can see, a TOC of 50 milligrams per liter results in a BOD of approximately 240. An effluent, we have one of our treatment plants again. It's both nitrogen and phosphorus removal with tertiary filtration. And you can see that in order to put together a correlation, we had to use BOD data less than 2 milligrams per liter. And so we just used the raw data and did not use a detection limit. But you can see that in the 2 milligram per liter BOD test would result in approximately 7.8 milligrams per liter of TOC. So just in a summary, what's been happening in the past and what should be happening in the future, we see that the BOD test was developed in the 1910s. At that time, we were using rock trickling filters, and its present advantages has just been used a long period of time, over 100 years by regulators. The COD test, while it was produced in the 1940s, the common treatment methods were rock trickling filters and activated sludge. And the biggest advantage it has is that all the computer models have been based on the COD test for the treatment plant processes. TOC, it was developed in the 1960s with highly sophisticated instrumentation that exists now. The most common treatment method is activated sludge, and its biggest advantage is it's fast and accurate. Now, the question is what's going to be used in the future. I believe that in the future we're going to have to do biological nutrient removal with ultrafiltration. And the question is, what tests will we be using in the future to characterize that improved performance? And what I want to throw out, or what people to think about, is can we develop new traditions? We presently express nitrates as nitrate nitrogen and orthophosphate as phosphorus. So and in addition, why can't we express then the organic matter as carbon? Or even going further, as we get more and more emphasis on removing trace organic compounds, why not characterize trace organic compounds as C? With that, I'll turn it back over to Jen.
All right, thank you very much. I just want to take a moment to thank all of our speakers today, each very wonderful presentations. We're going to get to some Q&A in just a second, so I have a few questions lined up. I'll give everyone another couple seconds just to get some more questions to me if there's anything from Dr. Drury's presentation. And I would like to start, though, with a question for all three of our speakers this afternoon. Have any of you considered using inline and rather online process control TOC analyzers? I know, for example, HOC is really big into online analyzers, especially for that process control situation. So is there any particular reason why it was stopped at just laboratory analyses as opposed to using that process control information with the online analyzers?
Well, this is Akin. There is a part of the city here that uses the online for source water monitoring TOC. The challenge that anybody would have with online TOC analyzer is a particle size. As Nell illustrated from our presentation, it is also true here in Santa Cruz that we have to homogenize the samples because of the internal diameter of our sippers, because we automate our TOC analyzer. It's difficult to see how you would do that online.
Yeah, this is Nell, and our agency has not implemented that at all, and partly because of what Ken just said, and I think maybe a little bit of cost issue as well.
This is Doug. If you look at the treatment plant operations, the biggest power input, the biggest emphasis, or the biggest problem for the operators comes in terms of oxygen and negative sludge process. And we have developed over the years a continuous monitoring of dissolved oxygen. And so that has sufficed for us to measure and operate the process as opposed to trying to measure the total organic carbon. So I think there's proven methods from an operation standpoint to control with DO as opposed to trying to control with TOC.
Okay, thank you very much. Now on to individual questions for the specific speakers. Nell, there are a few speakers who were wondering, as far as your industrial discharges, if your facility has any, and what type of typical chemicals are usually present in the influent, and how has that changed now versus before?
Let me make sure I understood the question. We do have industrial dischargers. We actually have quite a few. A lot of them are diverted to LA, and so we have to meet their COD or BOD requirements. We don't take any high brine type samples in this agency because we're an inland discharger, and LA can handle those better, as well as Orange County. So we still have to meet their requirements. So we haven't converted over to using the TOC conversion. Can you repeat the rest of that question? Sorry.
Not a problem. Basically, if there was any difference, any new industrial dischargers to the IEUA.
You know, I'm probably not the best one to answer that, but they're changing all the time, and we go from having food industries discharging to plating shops, and it varies, it kind of cycles through. So yeah, it does. And like I said, we have so many dischargers that it really does vary a lot on what we have coming in. I hope that answered the question.
All right. Moving on to our second speaker, Kim. There's someone who was wondering if you could just clarify, are you still running BOD, or has that kind of faded to the wayside?
We don't run BOD for either process control or for compliance monitoring. We run BOD for a fee. So if there was somebody in the service area who needed BOD done, we still have our equipment. They know the limitations of BOD, and it will cost them money.
All righty. Question for Dr. Drury. What was your effluent BOD permit limit compared to the newer TOC limit?
The effluent BOD limit was 30 milligrams per liter, average for the month. We do not have a TOC limit. What we do is we do a calculation from TOC to BOD and then apply the 30 milligram per liter limit.
Okay. One more question for all three of you, if any of you know the answer to this one. Has anyone, to your knowledge, used TOC in place of COD for process modeling?
We initially did that at IUA. This is now. And, oh, gosh, you know what? The process modeling question, you're right. Sorry, I might have misunderstood the question. I would say no, we still do use COD data for that. Although I believe we've gotten them to use the conversion, the calculation, because we had such a good correlation for TOC to COD that when they do use it, they use a calculation for the most part.
I've seen some models that use respiration rates and BOD. But by far the most common models that engineers are using is COD, using the COD.
We haven't done any modeling studies in Santa Cruz. The last study we did was in San Jose, and yes, we use respirometry rather than any of these methods.
All righty. Thank you all for that input on that. There's one question for each of our speakers again. Do any of you require the UBODT run? I apologize if I completely slaughtered that. I'm not entirely sure what the asker is referring to. I would imagine a different sort of BOD test, an ultimate BOD test.
We don't do BOD. I'm sorry. Go ahead, Dr. Drew.
I was going to say we do not use the UBOD.
And this is Akin. We don't do BOD at all. Whether
Right.
ultimate, nitrogenous, 5-day, we don't do any of them. We could do them if requested, and it would cost you money, but we don't do them.
Yeah, at IUA we don't either. We only do the standard BOD 5-day test.
Question for Dr. Drury. In general, how are the different matrices homogenized when comparing TOC, BOD, or COD tests? If you could just give an overview on those processes.
I'd have to ask our lab manager.
Fair enough.
He's here. It's about how, if I understand the question, is what homogenization processes we use for the different samples?
That's correct.
And it's just by the method, the standard methods method.
Okay. All right. So as long as the asker would follow that that procedure, they'll be able to duplicate the results.
I believe that's the case.
All righty. Another question, how long would any of you suggest, how many data points would you recommend for correlating for a correlation analysis prior to going to your state regulator?
I think you just have to do it enough to be comfortable, but each of the regulators are going to finally make that determination. In terms of plant performance, the plants perform differently on a seasonal basis. So my experience has been the regulators want to see a year's worth of data.
And I concur with that entirely. We did our study to cover all the seasons. So it was actually a 16-month study for us, and that's a minimum I would recommend.
Yeah, I concur. Ours probably went over almost 2 years of data collection. So a lot of data points is good.
All righty. Question for Dr. Drury again, or for any of you if you have information on it. Quite a few of the attendees have questions regarding the use of the TOC to BOD ratio versus just TOC to see correlation. Could you explain why there was the ratio instead of just TOC?
I did not present any data on the ratio. That was Akeem.
Yes, I did. And there were 2 reasons for the ratio. One was internal. One was to first decide whether there was something simple that showed that there was a reproducible relationship. And, that builds your confidence once you know that there is without going too much further. The second was intricate because BOD is inaccurate at very low levels, at anywhere from 10 to the 2 limit that's promulgated. High variability in all sorts of questions derived. So at that level, if you took the BOD data, whether raw data or transformed data, as it was, you couldn't graph it correctly. You saw that repeatedly, both from Inland Empire data and from my data and from other data that have not been published yet. You would have a glob. But the ratios are more distinct. You will be able to, as you saw, we had a reverse hockey stick in our effluent relationship. And that was the advantage of using the ratios rather than using the glob of in Clark County's data. You would have just had less than 2s, and in my case, you'd have had numbers you couldn't really trust beyond. That's what the method says it is. So that was the advantage of using the ratios.
All righty.
I have another comment.
Yeah.
Well, we did not present the information on the ratio. We do use the ratio in the laboratory to understand or to see how usable the data is, or acceptance for data. So we have a range of values that we accept.
All righty. Another question, and this good information just on the test in general. The BOD test allows detection of toxins if an analyst is able to get a sliding BOD. Is it correct to assume that the TOC test cannot do this because it's so broad and so general?
I'm not sure I understand the question.
The fact that it's a biological test, and in a sense a bioassay, does allow it to detect a certain amount of toxicity. There are other methods available out there that could measure toxicity, but I've never, because it's an issue of the variability in the test. So even though it can detect it, it's like yes or no if it's not there. If it's totally toxic, then you've got something major wrong, and you'll see it in the plant as well. So I have not used it in that manner because if it does detect toxicity, you'll see it in the treatment plant.
And the test will see it only 5 days after.
Yes. You'll know it from the treatment plant before you'll know it in the test.
Correct.
All righty. Question for everyone based on Nell's presentation where she included both influent and effluent TOC data. Have any of you looked at TOC for the influent as well, or are there issues with solids or occlusion of the tubing, any sort of fouling, things like that nature?
Yeah, the influence, as I said, you really have to homogenize them. The instruments themselves have fairly small sample lines, so you need to make sure that you get a sample line that is capable of handling a fairly large particulate, although by blending just your standard blender will do a pretty good job of getting that broken down. You do get a bit of scum sometimes accumulating, and in the purger, when you add the acid, you'll get a lot of buildup if you do it in the instrument purger. So that's why one of the reasons we use the sample vial itself to do that. That way you're not having to clean and you're not worried about crossover contamination. But yeah, it's very important to homogenize and very important to get a sample instrument that can handle the larger particulates even after blending. It's a big issue.
All righty. Would anybody else like to comment if they've tried using it for influent as well as effluent?
No, we use it for influent. We do use it for influent. Is that the question?
Yeah, but I'm trying to see if either of the other speakers, if either Akin or Doug have any experience or tales to tell about using that.
We use it, and in fact, I think in my presentation I said that was the first part to build our confidence that something could happen. It was at the influent, and yes, we still do use it in the influent. We homogenize it, as Nell said. You have to homogenize it, and in spite of that, in any case, you still have some occasional clogging clogging of the line. I suspect that part of that has to do with the experience of the laboratory, that you can spec internal diameters that are bigger than what I spec'd when I spec'd for our TOC system and all that. You can be more tolerant, but I was going for the finest possible particle size and all that. So you still have all of that in the influence to consider, yes.
You also need to make sure that you get a good mixing happening when you're pulling the sample through, because if you have any settling, you're going to lose all those particulates aren't going to get pulled into the instrument. So you have to have really good mixing. It's vital to get good data.
Right.
And I concur with the others. In addition, you have to do regular instrumentation maintenance because the solids going in will create problems over time. And then, in addition, I think we monitor the suspended solids as well and compare that to our TOC results just to make sure that we're in the ballpark and that we're not going to have a problem.
Alrighty. Have any of you, or do you know of any studies that have been done, not necessarily referencing TOC to BOD, the standard BOD 5 test, but to CBOD?
Do you mind repeating the question?
Yeah, there are quite a few attendees who were wondering if anyone has looked at the correlation between TOC and CBOD.
Oh, well, I probably should have said that when we started out, our BOD was described as CBOD. I refrained from using the C before it because of the ambivalence in the general use of that term. The questioner would remember that the difference between CBOD and BOD is that CBOD operationally eliminates nitrogenous compounds from participating in the oxygen depletion. And so if you look in standard texts for how to run it, you add the inhibitor through the test. But we had a tradition here of adding that only to the samples, not to the initial, blanks and all the other standards that participated in the test whose values you used. And that was controversial. So I just decided to call it BOD rather than CBOD because I didn't want to get into that argument. But functionally, most of those samples were CBOD samples.
All right. Thank you very much. 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 All right. Thank you very much
Ours at IUA was all BOD. That our requirements were BOD, sorry. We didn't have a CBOD requirement at all, so it was not evaluated at IUA.
We, here in Clark County, we did both at the same time. We did BOD and CBOD to get correlations. So we had all of that data.
All right, thank you very much. Now I know a few of you touched on cost of your individual processes and your individual machines. When you were researching where to purchase things, how did you go about choosing the instrumentation setup? What was the overall cost? I was just wondering if you could go over a brief guesstimate of, if any of our attendees would like to start to research this, what they should be going for further steps.
Well, my own experience with TOC instruments started in San Jose, and we had the Techman-Dorman instrument first before I took over managing that unit of San Jose's laboratory. And when I sent out requests for quotes, I compared all that I received from all of them, and I settled on the Shimatsu instrument. And so the cost was not significantly different, if I remember. This is almost 20 years ago. But the service, the proximity to us at the facility, and the service history with the older instrument convinced me at that time that the Shimatsu instrument was a better purchase. And so that was it. But there are all kinds of reasons, depending on where you live, where you work, to look at other instruments. Like I said, I had Techman-Dorman already in the laboratory there. IO also competed. And I had to consider the instrument that was least likely to present a challenge to the people operating it. You know, it was almost turnkey as possible. That was why I settled on what I settled on. It doesn't mean that the issue will be the same. Fortunately for all of us, there are many, at least 3 or 4 good manufacturers on the market.
I think that the people should select an instrument based on their own experiences or their experience of their staff in terms of what equipment they prefer. We chose Shimatsu to do our analysis.
We've been using the Techman-Dorman. In one case, we got a cost discount. We could trade in our old one for the new one. That helped. Nothing to say that Shimatsu doesn't produce a good product. The critical part for us was that it can handle the particulate matter. That's an important factor to make sure that they've designed the instrument to handle that.
All right, thank you very much. One last general question, and then we'll wrap it up. When, in addition to the instrumentation, when you were going through trying to talk to the regulators and getting all that data, what sort of resistance did you meet, other than needing to prove that the technology worked, obviously? What sort of steps did you have to go through in order for that to be accepted?
I think for us, there was issues of just they wanted more data. I think we had a good relationship with them, probably in part due to Doug. We had a really good relationship with them, and I think for us it was mostly just data. They wanted to see a lot of data. I don't think there was really a lot of resistance. It did take a couple years, but you know, any sort of regulatory change is going to. But I think we had a pretty good situation with our regional board.
The same can be said for us. We didn't have, in fact, we had cooperation with them. They called us to ask for the progress of the study once we alerted them that we were doing that study. It was of interest to them. The challenge, and I don't think it's resistance at all, came from EPA, because EPA thought at the time that nobody else had gotten, and by EPA I mean U.S. EPA, that nobody else had gotten TOC written into their permit. So they asked these questions, which are public questions, and they're iterated in our latest permit. And the largest question they asked was, why now and why you? And it wasn't the technical questions at all. And the answer was, well, the permit writer's manual encourages you to do things in the most efficient way possible. For us, going to TOC was more efficient than trying to build a room, an incubation chamber for 5 days that was going to hold samples. It will cost more to just make that one change just so that we could continue to do BOD, which value is not useful in process management, just so we could give EPA numbers, and they understood that. And so if you could give them numbers as well as meet your process control obligations for less money, they would go for it, and that was the challenge, and they went for it, and again, it's public documentation now.
I think you have to educate the regulators, and they have to become comfortable with both the TOC test and the BOD test. So you have to educate them about the deficiencies in the BOD test, at the same time the advantage of the TOC test. And then I think part of that is that to convince them that your QA/QC program is going to be adequate and that you're going to produce quality data. And once they see your QA/QC program, you have a reputation then for producing good data, and then with time, they have come around.
All right. Like I said, with that, I think we're going to finish up. Any final words of wisdom from our presenters to the lovely people attending this afternoon on where to go from here if they are interested in pursuing this further, in addition to the information that you've already said?
I would say good luck is all I can say.
Those are the words I was thinking. Good luck.
All right, that's comforting.
No, and it's not that hard. As I said, we did it almost 20 years ago, so it can be done. It was done then. I'm sure they're going to be more open to it now. So I think good luck isn't necessarily necessary. I think you'll have it. And feel free. I think my email address is on there. Feel free to contact me if you have any direct questions.
Okay. With that, again, thank you, everyone, for attending. Just another reminder, all of the slides are available on westnet.org. And as Nell just mentioned, if there are questions that each of you have, that any of you have for each of the speakers this afternoon that we were unable to get to, feel free to email them. They will not bite, I promise. And with that, again, thank you. Hope everyone has a good afternoon.
Thank you.
Thank you.
Thank you.
The organizer has ended the session, and this call will be disconnected. Goodbye.